Metamorphism. Metamorphism is the story of change. It's the story of recorded by the rocks and minerals of mountain building during plate tectonics. It's a solid state alteration of a protolith. What does that mean? Solid state means there's no melting that's occurring. It's just a solid change in the mineralogy and texture of a rock. The rock is a protolith. That's the pre-existing rock. So you can start with something like we'll go by a shale and turn it into a gneiss. So the protolith is a pre-existing rock. Metamorphism alters any protolith. If we look down here at the rock cycle, we can start with an igneous rock, weather and erode that igneous rock and turn it into sediment. That sediment can be cemented into a sedimentary rock. We add heat and pressure to that sedimentary rock, the shale, and we can turn it into a gneiss. So the solid state changes are slow. The changes are in the texture of the rock. Texture can be like the size of the crystals, but also like the orientation of the crystals. The mineralogy can change. The changes are brought about by changes in the temperature, typically an increase in temperature, changes in the pressure around the rock, changes in directed pressure. So tectonics creates pressure that is in one direction, and that can change the texture of a rock. There's also fluids that can react with the atoms in the minerals and create new minerals. So here's an example of a shale. It has quartz, clay, and it is cemented together with an iron oxide. Through metamorphic processes, we can grow new minerals and we can create foliation. So there's a foliation in this gneiss. A gneissic foliation are those light and dark bands. Those are nice light and dark bands. So this rock could have started as a shale, a sedimentary rock made out of mud, and ended up as a gneiss that has quartz, feldspar, biotides, and garnets in it. Texture changes can occur. We can start with a limestone that has fossils in it, and we can end up with a crystalline marble. Here is an example of a texture change, and it's an alignment of the platy minerals like the micas. We can start with a granite and end up with a foliated rock. Well, we'll use the gneiss again. The layers in it, those layers are actually an alignment of the muscovites, biotides, chlorites, where we have squished that rock and lined up the minerals. Recrystallization occurs. We can take small crystals, tiny little clasts in a sedimentary rock, or tiny little fragments in a limestone, recrystallize it, and those new grains would be much bigger. So we could take a micrite, which is like a lime mud, and recrystallize it into a shiny, crystally marble. Phase changes. So those were textures. This is a change in the phase. We can take one set of one mineral and we can change the heat and pressure and form different minerals. So this example is kyanite, andalusite, and sillimanite. And the 0 at the top would be conditions at the surface. Going down the y-axis is pressure, across the x-axis is temperature. As you increase depth, you're going to go from an andalusite in pressure to a kyanite. If you increase the heat, the rock gets over, the minerals change over to a sillimanite. I have kyanite on my necklace here. That's kyanite. It's just a coincidence, huh? Anyway, metamorphic minerals. They can change with heat and pressure. So it's like a pseudomorph. They have the same chemistry, but they're changing because of heat and pressure. All right, new minerals can grow, neocrystallization. So in this example, we have clay and quartz in a pluralith of a shale. And during, where's my shale? Here's my shale. Take a shale and you can heat it and turn it into a schist. So this is the example is a quartz garnet mica. This one has a little bit extra, but this would be similar to that. Through metamorphism, you're growing these new crystals. Okay, plastic deformation. This is best seen, this image here is under a microscope, where we've taken spherical grains and sheared them and squished them, and so we're changing the shape of the grains as the metamorphism and the deformation occurs over time. So this, you're going to have to heat up the rock to get it a little squishy, and then that pressure is going to change the shape of the grains.